Lab 4. The Physics of Extreme Sports with Ropes. The purpose of this lab is to analyze the physics associated with extreme sports that involve jumping from high elevations while attached to ropes. An analysis will be concluded by examining the motion of a spring mass system in which the mass swings in an arc while oscillating on a spring. The motion of an oscillating mass spring system will be described using Newton's second law and the energy principle. As the mass oscillates, it is subject to two forces, gravity and spring force. The change in momentum at each time stamp is related to the new force of the mass through Newton's second law of motion. F net equals dp over dt. The force of gravity pulling the mass downward and the spring force pulling the mass upward make up the net force of the oscillating mass. In the model, Newton's second law is used to calculate the velocity changes throughout the oscillations. The energy principle was used to track energy changes. If energy is conserved, the sum equals zero. Tracker was used to obtain the position versus time data, determine the period of oscillation, and establish initial velocities. The position versus time data was exported to a CSV file for upload to the computer model. To establish the initial conditions, first I used the y position versus time data to determine the period of the oscillation in the vertical direction. I determined the time between 3 oscillations and divided by 3. Secondly, I established the initial conditions, the period t equals 1.65 seconds, the given mass, which is 0.402 kilograms, and when calculating the spring constant, I substituted the known values to show k equals 6.83 newtons over meters. Next, I determined the relaxed length from the video. Finally, I established the initial x and y positions and the x and y velocities using the tracker data. I updated the code to show that the initial position equals negative 0.7 in the y direction, initial velocity equals 0, spring stiffness equals 6.83, and relaxed length equals 0.123. I ran the model to see the correlation between the physical position data from tracker and the position data calculated by the model. The red line represents the physical data and the blue line represents the model. As seen in the graph, the model accurately predicts the motion of the mass spring system, yet it does not fully show the predicted values of the oscillation. Next, I ran the model to track energy changes calculated by the code. The colored lines on the graph are defined as blue equaling kinetic energy, red equaling spring potential energy, green equaling gravitational potential energy, and yellow equaling the sum of all energy changes. What does it mean? Is the energy principle satisfied? Yes, from the model we observed, the energy principle is satisfied. Spring and gravitational potential energies oscillate with the same period as the vertical position of the mass changes. When the spring potential increases, the gravitational potential energy decreases by the same amount. Changes in kinetic energy are positive and negative as the mass oscillates. The sum of all changes is 0, which is expected based upon the energy principle. The period of oscillation in the horizontal direction was t of x equals 1.65 seconds. The period of oscillation in the vertical direction was t of y equals 1.52 seconds. The horizontal motion is calculated using the equation for a period of a pendulum. The vertical motion was calculated using the equation for the period of a spring. The calculated period represents a percent difference of 2.03%. Certainly, this very low percent difference is within acceptable experimental error and is most likely due to the error inherent to collecting the tracker data and the fact that the relaxed length is not constant since the spring is not rigid. In conclusion, using Newton's second law, the model accurately predicted the motion of the mass spring system in both the horizontal and vertical direction. The model demonstrates that the energy principle is satisfied by the analysis of motion. Finally, the vertical motion is accurately modeled as a mass spring system, while the horizontal motion is more accurately described by a pendulum motion. Thank you for watching.